Welcome class 10 in our first video of chapter number 1. Myself Murabur Hussain and I am going to introduce this chapter. So firstly, the chapter name is real number. So what about real numbers? What are real numbers? So we are just recall some of the type of numbers like natural number. Everyone knows counting numbers are called natural number. Example 1 2 3 4 xyz. Whole number, counting number with 0 are called whole number. For example 0 1 2 3 4. And next number are even. Even numbers are those which are divisible by 2, and the odd numbers which are not divisible by 2. Prime numbers which are divisible by 1 and own itself. The another definition is the numbers which having only two factors, 1 and own itself. The number which having only two factors, 1 and own itself. Okay, composite number are the opposite of prime. Okay, the number which are not prime numbers are called composite number. Like that 20 have so many factors like 1 2 10 5 4, all the factors of 20. So 20 is a composite number, not the prime number. Okay, now rational number are those which can be converted in the form of p upon q, or are in the form of p upon q where q is not equal to 0, or we can say that according to the lower classes, numerator upon denominator of fractional numbers are called rational numbers. Okay, so irrational number which cannot be converted in the form of p upon q, that's why the number are called irrational number, like under root 2, under root 3, under root 7. We are giving just a simple trick to understand the number is irrational or not. Under root n, when n is a prime number, under root n is a prime number, then under root n is a irrational number. We have also n equal to 1 2 3 4, not 1 2 3 4, n is equal to prime number, only the prime number, then under root n is the irrational number. Okay, so another form of irrational number is 0.001, 0001, 00001 dash up to infinity. We can include all of the numbers in this situation. Okay, so the next type of number is integers. Negative and positive numbers are integers. So all of the numbers, natural, whole, even, odd, prime, composite, rational, irrational, all are the numbers. All the numbers are real number. It means irrational number, rational number, every of the number are real number. So another form is imaginary number, which we will study in our class 11. Imaginary number, or we can say that complex number, okay, which are not real number. We just imagine the number in the form of iota. Okay, so let's introduce this chapter. What we have to study in this chapter, that is Euclid division lemma. The next one is fundamental theorem of arithmetic, and the next revisiting irrational numbers, and also revisiting rational numbers and their decimal expansions. Okay, so the first thing is, what is Euclid division lemma? We have a theorem in our class 10th NCERT book, that is, given positive integers a and b, there exists unique integer q and r satisfying a is equal to bq plus r. 0 is lesser than equal to r and r is lesser than equal to b. So according to this, it is not easy to understand. So a is equal to bqr means bq plus r means dividend equal to divisor into quotient plus remainder, which we have studied in our lower classes. Dividend is equal to divisor into quotient plus remainder is the required Euclid division lemma. But what the word is using lemma? Most of the time we are using words lemma. What is lemma? Lemma is a proven statement. Used for proving another statement. Again listen, lemma is a proven statement used for proving another statements. Okay, this one is a lemma. So we are just taking a simple example on the basis of Euclid division lemma or Euclid division algorithm. So the example is use Euclid algorithm to find the HCF of 455 and 42. So we can write 455 as 42 multiplied by 10 plus 35 by the process of division. I am showing you here. So 445 is the dividend, 42 is the divisor, 10 is the quotient and 35 is the remainder. Again we are taking 42, we can write 42 as 35 multiplied by 1 plus 7 by the process of division. Similarly 35 equals 7 multiplied by 5 plus 0. So the remainder is 0, the process stops. So we can say that HCF is 7. HCF is 7. So now we are just moving on our next exercise, that is exercise 1.1. So this is the first exercise of this chapter. Use Euclid division lemma. The very first question is use Euclid division algorithm to find HCF of, I am doing only the first question, 135 and 225. Next of the question, do yourself. If you have any problem you can comment, I will solve in next video. Okay, so which number is greater in both of them? 225 is greater than 135, and again 225 can be written as 135 multiplied by 1 plus 90. Dividend is equal to divisor into quotient plus remainder, or we can say that A is equal to BQ plus R. And again take 135, again take 135, 90 multiplied by 1 plus 45 we can written. So again take 90, so 45 multiplied by 2 plus 0. So the process will stop. Okay, the process stops. So the remainder is 0 and the divisor is 45. So the last divisor is the HCF of the two numbers. Okay, HCF means highest common factor. Okay, so next question, question number 2. Show that any positive odd integer is of the form 6 cube plus 1 or 6 cube plus 3 or 6 cube plus 5 where q is some integer. So before solving this question we should understand what is the form of even number. What is the form of even number? The form of even number is 2m. Okay, the form of even number is 2m and the form of odd number is 2m plus 1. How we can write 2m? How we can write? Suppose we are taking any of the number. Let's say we are taking prime number. Prime number doesn't have any type of factors more than 2. So we are taking prime number like 17. 17 is a prime number. So if you want to make it a even number, so multiply it by 2. So 2m equal 2 multiplied by 17. So 2 multiplied by 17 is equal to 34. So 34 is the even number. Yes, so the form of even number is 2m. So again take 17 as prime number. So we are making it odd number. It is an odd number, but we are again making it odd number to odd number, or we can make even number to odd number by the form of 2m plus 1. Okay, so 2m plus 1 equal 2 multiplied by 17 plus 1, 34. 34 plus 1 is 35. So 35 is odd number. Again we are taking even number to make it a odd number. So we are taking even number as we also know 2 is the even number. 2 is even number. So 2m plus 1 equal 2 multiplied by 2 plus 1. So what will be the result? Result is 5 and 5 is odd number. So just remember it again. 2m is the form of even number and 2m plus 1 is the form of odd number. So again study our question. Show that any positive odd integer is of the form 6 cube plus 1 or 6 cube plus 3 or 6 cube plus 5 where q is some integer. Okay, so by Euclid division algorithm we can write a is equal to 6q plus r. because the form is 6q plus 1, so we are writing 6q plus r. Okay, for some integer q is greater than equal to 0 and r is equal to 0, 1 2 3 4 5 6, 1 2 3 4 5, just we are taking 1 2 3 4 up to 5. Okay, because 0 is lesser than equal to r or r is lesser than 6. Okay, what is the meaning of lesser and equal? So r is lesser than 0, r is greater than 0 here, and equal to 0 also. So therefore a is equal to 6q, or a is equal to 6q plus 1, or a is equal to 6q plus 2 as soon as possible, because we are taking 5 numbers. A is equal to 6q plus 5 is the last result. Okay, so just take first of the number 6q plus 1. Okay, so we can write it 2 multiplied by 3q plus 1. We can write it 2 multiplied by 3q plus 1. So here 3q we are taking just m. So let 3q is m here. Okay, 3q is m, so 2m plus 1, which is the form of odd number. So just remember the question is saying show that any positive odd integer is the form 6q plus 1, so the form will become 2m plus 1. So the number 6q plus 1 is odd, so 6q plus 2 just leave it, and 6q plus 2 is taking, so 6q plus 3 is equal to 2 multiplied by 3q plus, we can break 3 as 2 plus 1, so just take 2 common, so 2 bracket 3q plus 1 is the result, plus 1, because we have taken the 2 common, so we close the bracket, plus 1, so the answer will become 2m plus 1. Again 2m plus 1, because we are just taking bracket as m. Okay, so take again 6q plus 5, so we can write it 2 multiplied by 3q plus 4 plus 1. Again take 2 common, so the in bracket 3q plus 2 bracket close plus 1, so again 3q plus 2 is the form of m, so we can write it 2m plus 1. So hence any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5, where q is some integer. Okay, so if you want more videos like this, just comment, share, subscribe and follow us on Instagram also. Thank you everyone.